Hi all, welcome to i-tutor Academy. In today's session, we will start with the unit 12, subsection 15. So this is the last part of unit 12. It's lengthy unit. And today we will discuss exchange curve and uh, aggregate inventory planning. Okay. So concept of exchange curve. The exchange curve or optimal policy curve, also known as optimal policy curve, is an effective technique to look at the inventories at an aggregate level in the organization. So it is a plot between the total number of order, that is TO, total number of order per year, and the total investment in the in per year. Okay, total number of order and total investment of the year. And the rationale is that for an optimal inventory policy, the trade-off between total inventory and total procurement effort, as indicated by the total number of replenishment orders per year, must be made such that if total number of order are prescribed and we minimize total investment in inventories. And alternatively, if the total investment in inventories is prescribed, then a rational inventory policy must aim at minimizing. Optimal inventory policy must exchange TI for TO in such a manner that. So this is the equation for that, and please refer. So this is the exchange curve. Okay, here is total number of order per year and a total inventory. So this is the exchange curve. So here and use of exchange curve is an effective instrument for aggregate inventory analysis to quickly determine the rationality or otherwise of our existing stock provisioning policies. And we first plot the exchange curve by computing the value of K for a chosen group of item. Then we determine the total number of order, that is TO, and total investment in inventories under current practice. And if the current practice is at point, that is C, above the exchange curve, then it shows that our present procurement policies are not rational. And if we want to rationalize this, then there are two possible paths, AC or BC. And so that we reduce inventory to B for the same ordering effort, or reduce number of orders to A for the same inventory. This exchange curve is a useful device at a macro level. Okay. Next is deterministic inventory model, that is classical EOQ model. In this section, we discuss some elementary inventory models with a deterministic demand and lead time situation. The purpose is to provide an illustration of the mathematical analysis of inventory system. And the most classical of the inventory model was first proposed by Harris in 1915 and further developed by Wilson in 1928. So it is popularly known as EOQ, that is economic order quantity model, or Wilson's lot size formula. And when dealing with stock item, the two important decisions to be made are how much to order and when to order. And EOQ attempt to provide answer to former, while the reorder point, that is ROP, provide the answer to the latter. And the following assumptions are made in the standard Wilson lot size formula to obtain EOQ, that is demand is continuous at a constant rate and the process continues infinitely, and no constraint are imposed on quantities ordered, storage capacity, budget, etc., and replenishment in is instantaneous. The entire order quantity is received all at one time as soon as the order is released, and all costs are time invariant and no shortage are allowed, and quantity discount are not available. And the inventory status under EOQ ROP policy is continuously reviewed. And here is the figure: inventory behavior under classical EOQ model and the total cost curve under EOQ model. So these are the two figures. Okay. And let us use the following notation in developing the classical EOQ model is demand rate, unit per year, and ordering cost, that is there, and inventory carrying a charge per year, annual cost of carrying inventory, that is there. Okay, so here is an equation. Please go through your study material, Mmpc 009, unit 12. Okay, so here is finite replenishment rate, section 6.3. Also please refer parallelly. Okay, you will get an idea. And inventory behavior under finite replenishment rate is here, so please refer this figure. Okay, so here is inventory level is there. And now relax the assumption D of the classical EOQ model and permit the finite replenishment rate When the rate of procurement is P in unit per year and the demand rate is D in unit per year, the buildup of inventory is at a rate that is due to simultaneous consumption, and it is obvious that P greater than D for inventory to build up. Okay. And next is some interesting observation can be made about the behavior of such system. These are Q under the finite replenishment rate are higher than Q under the classical EOQ model for the same value of the other, and total system cost under optimal Q is lower than corresponding total system cost under EOQ model. So this is based on all equation based, so please refer this. And planned backlogging. What is planned backlogging? Let us now consider the effect of relaxing assumption of classical Wilson's model by permitting backlogging, that is shortage or back ordering at a unit shortage cost of S is RS rate and unit per short per year. In such a case, negative inventory shows the backlogging position. So the order quantity Q is partly used to clear the backlogging level B, and Q minus B is the maximum stock level. So here is again the figure inventory behavior with the planned logging. So this is inventory level, here is time, so inventory behavior with the planned logging is here. Based on that equations also here. Okay. And some useful observation could be made about the behavior of inventory system with the planned backlogging as follows. Okay, the total system cost is lower with the planned backlogging than the corresponding total system cost under classical Wilson's lot size formula. Thus, for a deterministic system with the finite backlogging cost, it is economical to plan for backlogging, and it can be seen that at a S, the model of reverts to classify EOQ model, and EOQ under black backlogging is higher and maximum stock level is lower than the corresponding values under classical Wilson's lot size model. And if S is equal to 0, B is equal to Q is equal to sigma. So this means that with no charge for back order, one would keep piling up unfilled demand until the backlog gets infinitely large. And then one single order would be released to satisfy all accumulated demand. And however, considering intangible cost of back ordering such as loss of goodwill, etc., so it is debatable whether there are situations when the cost of shortage S is really zero. And model with the quantity discount, frequently the vendors offer quantity discount on bulk purchases to encourage users to place orders in large quantities, and quantity discount may be all unit discount or incremental incremental quality discounts. In all unit discount, entire order quantity is purchased at lower unit price if order size is higher than or equal to the stipulated conditions. And in incremental case, only quantity exceeding the threshold point is charged at lower cost, and the immediate reaction may be to avail the discount and place bulk order. But if we see the total system cost, our decision may be otherwise. So there may be a single multiple quantity discount. So here is the figure. This is total cost curve under quantity discount. So discount level 1, 2, 3, 4 are here in this diagram. And the broken lines show the total cost curve without price. So this is the broken lines, whereas solid lines show the actual total cost if price break taken. uh, this is the solid lines, this is breakdown lines. Okay, so these are the difference, and the larger number of price breaks, the more difficult it become the analysis the situation, as more alternative are to be evaluated. The important point to be made in such a situation is that individual situation is to be analyzed to judge which of the option is suitable to avail discount and place bulk order to make it realizable, and reject the offer and place small order at a higher unit price, or place order at the minimum possible quantity at which discount become valid. And next is sensitive analysis. If may not be operationally very convenient to stick to EOQ if it is an odd figure, and then one may like to know the repercussions on total system cost if one deviated either way from Q, and this is done through sensitivity analysis. Okay, so here is equation. based on that. And next subsection is inventory control slow moving item. So nature of slow moving item, as stated earlier, slow moving material are those which are not regularly demanded, and their movement of the shelf is very occasional, say once in 6 months or so. An example of slow moving material can be spare parts and some special purpose material for project required only for a certain kind of project activity. An inventory models valid of regular demand pattern, and generally slow moving item are quite expensive, and therefore one has to first decide whether to keep them all in stock, and if to keep them in stock, then what quantity. And further difficulty of slow moving parts is the initial overbuying decision, which could take years to remedy the situation due to rarely occurring demands. And some inventory policies for slow moving spares. We shall illustrate our approach to manage the inventory of slow moving item with the spares inventory problem, as a substantial percentage of spares come under the slow moving categories. Some of the strategies that could be possible adopted for efficient inventory management of slow moving spares are as follows. And if spares are required only at a pre-specified time, such as at the time of major scheduled maintenance for replacement, then it is better not to stock them but to place procurement order sufficiently well in advance, keeping lead time in mind, and so that these arrive just in time when these are needed. And if the part gives adequate warning of impending breakdown, then also the best policy is to place an order the moment we get the warning. And adequate warning refers to the case when the lead time required is less than the warning time, and this shows that major improvements in slow moving inventory are possible by cutting down the lead time. And for inadequate warning spare, we must keep the stock, and generally maximum stock level will be 1 or 2, or 1 for 1 ordering policy is very useful. This means placing an order for one spare when one is consumed. And next is recent developments in inventory management. So, multi-echelon inventory system. The inventory model describes in the preceding sections pertain to situations where the stock is located at a single place. In practice, the stock may be distributed over several locations. An example, in multi-project organization, there may be central store and number of field stores or project stores, and such a type of inventory system are called multi-echelon inventory system. Since the inventory in all the location belong to the same system, and it is better to look at the inventory management for the system as a whole rather than treating each storage location independently. And recently, a lot of attention has been given by the researchers to the analysis of such a multi-echelon inventory system. Important decisions concerning the design and operation of such a system are the number of echelon, number of storage point at each echelon, that is level, location of central store, optimal inventory policy to be followed by each storage location, and the stock distribution policies, etc. For very expensive slow moving items such as complex assemblies, it may be desirable to locate the inventory at the central store rather than at the project store, provided the item is standardized and is usable at each location. Detailed mathematical analysis of multi echelon inventory system tended to be rather complex and is beyond the scope of this unit. So you can refer 6.5 also section. Okay, so summary of this unit is here. So summary is: purchasing in ordering sense is the procurement of material, component, machine, equipment and supplies, etc. on payment. And in the present environment of frequently varying price condition and increasing material variety and competition, the purchasing function needs professionalism to reduce the total investment in purchase while making the required material of right quality available on time. And the purpose of this unit is to present and discuss various aspects of purchasing to achieve this professionalism. And major topic discussed include scope and objective of purchasing input, and environmental and management factors influencing the purchasing decision, and purchasing decision procedure, forms, records and reports, procedure, evaluation, vendor evaluation and organization for purchasing. And the presentation and discussion are aimed at an efficient information flow amenable for computerization. An efficiently designed purchase system with appropriate procedure, forms, and information flow can generate the report with the required content intended for specified destination at various level of management in the organization. And this unit has also attempted to highlight the role of inventory management in the successful operation of any production or service system, and functions of inventory and various inventory related cost parameters have been identified, and various operating inventory policies have been described. ABCVED FSN analysis concept have been outlined to enable selective control on inventories, and the role of exchange curve to quickly detect the irrationality of existing procurement practice has been highlighted. And some deterministic model to determine EOQ are presented, and sensitive of classical EOQ model is analyzed. And impact of demand or lead time variability on reorder point and buffer stock has been explained. And problems of slow moving in item inventory control has been identified, and some guidelines have been given. And recent developments in inventory management have also been touched. And keywords are here from this section. If you feel any words are difficult, please refer this section for the explanation. And self-assessment questions also here. It will help you for your term and examination, like assignment. So it's also important. Please do it one by one. In between any doubt, you can contact us anytime. So here is around 17 questions are sorry 9 questions are here. So do it. It will help you. And this is about today's session. And for more MBA series, you just do like, share, and subscribe our channel. Thank you so much.